In chapter 12, we find that there's quite a bit of reference to the letter I in complex numbers, and we didn't cover that. So what I'd like to do is to give you some background, and we do want you to include this in your notes as sort of an extra page or so. Now, complex numbers is sort of a big umbrella of, on one side, numbers that we've talked about throughout this course, real numbers, and I'll give you a little more background on this as well, and then imaginary numbers. Now, imaginary numbers, even though they say imaginary, they are actual numbers. And it's useful in our calculations. And the combination of these imaginary numbers now and the real numbers make up our complex numbers. So, like real numbers, all the numbers on the number line, we now add an additional group of numbers and put all of them in this category of complex numbers. Okay, so let's take a look at some background detail here. So we'll center that a little bit here. Now, if you go back into the beginnings of our course, we didn't cover these in any great detail because they were assumed that you had a lot of information about them. But these are the different set of numbers that we deal with in our mathematics courses. One set of numbers are the natural numbers. 1, 2, 3. And then our ellipsis goes on to positive infinity. Then the next set of numbers are called whole numbers. And again, write these down. I'll try to keep it short. Now, the difference between natural numbers and whole numbers is that whole numbers we add a 0 to it. And it goes on to positive infinity. Now, and I think we could use a number line here to help us a little bit. Now there's our 0, and there's 1, 2, 3, 4. So 1, 2, 3, 4. If we were going to graph these sets, and I'll change colors here, to graph whole numbers, we'd put a dot on 1, natural numbers first, 2, 3, and this would go on to infinity. And then whole numbers, we put a dot on 0, and that's the only difference, and that goes on to infinity. But now when we get to integers, we're looking to the other side of 0 here a little bit, where it's -1, -2, -3, -4. So if we have our whole numbers and their opposites, the opposite is when you add a 1 and a -1, it makes a 0. A 2 and a -2 makes that 0. And if we then graph these, we get our set of integers. So this would be coming from negative infinity out here, and then starting, -2, -1, 0, 1 to positive infinity. This is a set of numbers that are called the integers. Now, on the number line, there are other numbers. For instance, between 0 and 1 and 2, there is what we call the square root of 2. And that's about 1.4, right about there. This is where the square root of 2 is. And we did work with radical numbers that are not perfect squares. And if you were to put, let's say, 1/2, which is like right here, into its, on the number line, which is a fraction, these fractions, along with all the other integers, if you were to convert them to decimal fractions, this one is 0.5, it terminates. Now another one, and I'll change colors again here, is about 1/3, which is right about there. If we were to convert that to its decimal form, that goes 0.3, and it's 3, 3, 3. It keeps repeating, and we often write it as 0.3 with a bar over the part that repeats. Fractions that terminate like this in their decimal form, or have a repeating pattern in their decimal form, these are the rational numbers. So fractions that terminate or repeat in their decimal form, and that includes all of the integers, whole numbers, and natural numbers as well. These are the rational numbers. Now, those numbers, such as the square root of 2 and the square root of 3, those numbers that are not perfect squares, because if you have the square root of 4, this is actually a 2. So 2 would be a natural number, a whole number, an integer, and rational, even though it's under the radical sign. But the square root of 2 is not rational. That is, it doesn't terminate or repeat. It just continues and continues. These are the irrational numbers. So this would be the square root of 2, and all the others, square root of 3. Now it also includes pi, which we say is irrational, and a number we had earlier, the letter E, is irrational, and there are others, I'm sure. So that would be the set of irrational numbers. Now, all of these numbers that we've talked about so far are on the number line. So they make up this set of real numbers. And this is all the numbers on the number line. Now, we get to our complex numbers, because we have been saying that the square root of -4 is not a real number. It's not on the number line. So let's go on and do some work with that. So we can agree upon that the square root of -4 is not a real number. And eventually we will classify it as a complex number that we described earlier. Now, how do we deal with these? Well, the scientists and the mathematicians working with this some years back said, well, we could tease this apart into two radicals, where if we took out here a square root of -1, and then what would be left here is the just a regular 4, then we could use this symbol, the square root of -1, and instead of writing it this way, replace this square root of -1 with the letter I. And I is related to its imaginary nature, although it's a number, it's in the system, it's just not a real number, and the letter I stuck with it over the years, and we still use it today. So this would be I then, the square root of 4. So the square root of 4 we know is 2. So this is going to end up being 2I. And that's what you need to remember as far as complex numbers, and I think I've mentioned this. Now, the other thing we need to use for background here is that if we had I, well, let me put it this way here. Do this again here. If we had the square root of -1 that we squared. Now, recall there was a index 2 number 2 here. We don't write it if it's a 2. And we had said in an earlier lesson that if we raise what the index number is to that power, it just becomes the radicand. So that is a -1. Now, since we're saying the square root of -1 is an I, another way to look at this is I squared. So I squared equals a -1. Now, we have said that, we just didn't show you the mechanism for it. So, that's about all we need. And then the idea that we've already mentioned, that whenever you have, let's say, a -4 I squared, we don't leave it in this form. This is a -4, and then we're saying I squared is a -1. This becomes a +4. And that's, we have mentioned that. But now, hopefully you have a little bit of background about complex numbers and where they fit in to the calculations we have been doing. And I will actually show this ahead of time, or ask you to watch this ahead of time before you start Chapter 12. Okay.